Your sense of self as you know it is about to be challenged. Not gradually, not symbolically, but technologically. We are entering a world where the boundary between mind and machine is no longer metaphorical. A world where thoughts may be read, written, optimized, and extended beyond the biological brain. And this forces a question more unsettling than any technical challenge. Will you still be you when your consciousness no longer ends at your skull? Brain-computer interfaces promise something extraordinary. They promise restored movement, speech for those who cannot speak, vision for those who cannot see. What once sounded like science fiction is now experimental reality. Electrodes connect neurons to silicon. Signals once locked inside the brain now flow outward to screens, machines, and networks. At first, this looks like medicine, and it is. But medicine has a way of becoming infrastructure. Every transformative technology follows the same path. It begins as repair, then assistance, then enhancement. Glasses corrected vision, phones extended memory. Algorithms now guide attention and desire. Neural interfaces will not stop at restoring lost function. They will optimize focus, accelerate learning, stabilize mood, perhaps even filter unwanted thoughts. And once cognition becomes adjustable, identity becomes negotiable. We tend to think the self lives inside the brain, but philosophically that was never obvious. Your identity is not just neurons firing. It is memory, language, normativity, history, and social recognition. Now imagine part of that system runs outside you. Your thoughts rely on external processors. Your recall depends on cloud-based memory. Your emotional regulation is partially algorithmic. Where does you end? If your mind is distributed, is your self distributed too? For centuries, one thing defined mental life: opacity. No one could directly access your thoughts. Your inner life was, by default, private. Brain-computer interfaces challenge this at the root. If neural signals can be decoded, they can be monitored, stored, analyzed. Who owns those signals? You? A corporation? The state? An insurance algorithm? Once thought becomes data, privacy stops being a moral assumption and becomes a contractual clause. Now imagine this scenario. A neural implant assists your decision-making. It predicts outcomes faster than you can. It nudges you, subtly, toward better choices. One day, a decision causes harm. Who is responsible? You? The software? The engineers? The training data? Traditional ideas of agency assume a bounded subject, a clear locus of control. Neural augmentation fractures that assumption. Responsibility becomes distributed, but punishment never is. We like to believe we are choosing these technologies freely, but technological environments do not ask for consent forever. They normalize themselves. Once neural augmentation becomes competitive in education, work, and creativity, refusal becomes a disadvantage. At that point, the question is no longer, do you want this? It becomes, can you afford not to have it? And that is not freedom. That is coercion without force. Here's the paradox. The more cognition becomes optimized, the more meaning risks thinning out. Understanding is not speed. Insight is not efficiency. Wisdom is not output. Some dimensions of thought emerge from slowness, error, ambiguity, and resistance. A perfectly assisted mind may perform better and understand less. Not everything valuable in thinking is computable, and not everything computable is worth becoming. So the real question is not whether brain-computer interfaces will work. They will. The real question is, what kind of selves will survive their success? Because when consciousness extends beyond the skull, identity becomes a design problem. And once identity is engineered, something profoundly human is at stake. Not intelligence, not power, but the fragile, imperfect space where meaning still happens.